mostly because the things that it asks you to do are entirely imperative in nature, which means you should be able to do everything that it asks you to do in like C-ish. There's some things obviously that that we will go through that question 2 and 3 you won't be able to do it imperatively. That will be a bit more fiddly to work through. But 1 and 4 you should be able to do it like C or Java or whatever. It's very straightforward and standard stuff. So conceptually, I hope you can at least do 1 and 4, even if you can't, even if you're not sure about the syntax that you have to give. So let's start, shall we? Let's start by implementing fit imperatively using a loop, using an iterative loop. So how would you? So it asks you to use 2 reference values. How would you do this? Okay, so let's declare 2 initial values A, B. What are their initial values?
0 and 1.
Okay. So we say 0. Right. The let construct here in OCaml is basically the same as Haskell, except that in OCaml you cannot declare a block of let. You have let is only one binding at a time for OCaml. So you are going to have to, every line needs a let for every variable you want to declare. I say variable, but you know they're all immutable. So ref declares a reference variable, which will basically work like your standard variables in Java and C and whatnot.
Sorry,
Yeah.
How do I make this larger? Let's try. This is better. This is okay. So ref will declare reference variables as, they will declare modifiable variables. The only difference is that in the syntax for updating and reading these reference variables are different. To read a reference variable, you would use the exclamation mark. So exclamation mark A will get you the current value of A. Current value of A. And then that is just a value. If you want to update A, you would say this, where E is some expression that has the correct type, obviously, and this and A will get updated with the new value. Yes. So there are 2 iterative loops in OCaml. One is a for loop, one is a while loop. The syntax refer to lecture notes. It should be there because we'll see them soon enough. So the syntax for a for loop goes for, you declare some variable, you declare some initial value, and then you can go upwards to some final value, or you can go downwards to some final value. These endpoints are inclusive, which means your variable v will end up taking both values I and f at some point. So they are inclusive whether it goes up or goes down, it's both inclusive. So you have to go up or go down. If we let's just follow the original code. So are we going up or down? Okay, so we're going down. Let's give our index variable the name I. What's our initial value? Okay, from top down is n because we're going downwards. So where are we stopping? What's the last value that we need to care about? what do we do? How do we compute the values that we need? How do we update A and B so that they have the correct values?
A equals to B, B equals to A plus B.
So A equals B, and B equals to A plus B.
The other way around, right?
You want to do it the other way around?
Because B is
But that one, the B will, both A and B will be the later value.
I think we did a temp here, right?
Okay. So we have a temp.
Temp equals to A plus B.
Okay, that's fine. A plus B. So what's B? What's A?
A equals B.
A is equals to?
B. B is really long.
A is equals to what? B is equals to what?
A equals to B, then B equals to 10.
So A equals to B.
But I think A equals to B should become first, right?
Okay. So we do that first, then B equals to temp. Done. Then done, and done signals the end of the for loop. The semicolons are here to, semicolons in OCaml are special. They don't denote end of an expression or end of a statement. Instead, what they do is that they'll ignore whatever expression that is attached to and just return unit. That's useful when you don't really care about the result, but you still need to compute some result, which is why these things need to be done, but we don't care about the result because we've already stored the result elsewhere. So we're using the semicolon to basically just ignore all the output, and then of course to return the value, we just return A or B. Should we return A or B to get the Fibonacci value? B. So say B. Okay. So let's test this out. Right. So if our fit in is correct, then the two values should be the same. So let's test. Very good. They're both 89. That means it's correct. My standard, right? So it's just it's basically just you're just doing this in the same way that you would obviously have done long ago before and whatever. It's just the syntax. The syntax will be new, so you're going to have to get used to how we write the imperative code in OCaml. So the for loop is implemented as follows. What's the polymorphic type of for loop? So let's figure out, right? What is the type of init? Okay, so we say that input init and final are both integers. What is the type of statement? What is the type of statement? Looking at how statement is used. So statement is a function. What's its input? What's its output? How many inputs does it have? How many outputs does it have?
It's in an int.
Okay, it takes an int. It takes an int and then takes an int. What does it return?
Returns the int.
Yes, it returns anything, right? Because it doesn't matter what it returns because we end up using the semicolon, we're ignoring whatever the output of statement is. So it returns anything. It doesn't actually matter what it returns. And if it doesn't matter what if it doesn't matter what it returns, we just say it returns some value of type A, which basically just stands for any possible value. And what is the final result of this function? What's the final output result? Final output type of this function for loop.
It's a list.
It's a list, right? You see what? Looking at the body of for loop, where does the final result come from?
The bracket, some STMPI,
Yeah,
the then
we call this unit. Remember in Haskell, this thing is called unit. Haskell just uses a symbol directly. OCaml gives it. OCaml requires that you write the name in the type context, right? You can tell that from for loop, right? There's this let in here. This means that whatever the result of ops is, right? Whatever the result of this function is, the output, the result of the for loop is basically the same as the result of ops. You can tell from the function body. That's clear, I hope. Right? You look at the function body, you can tell that this is the last expression. Therefore, whatever result it gives must be the result of your function for loop. So then, the only thing that we care about now is ox. What is the return type of ox? You look at the body of ox, right? There's only one expression in ox, which is an if-else expression. If-then-else expression. Now, you know that the if-then-else expression must have the same type on both branches. Alright? So if the else branch has type unit, then then branch must also have type unit. That's clear, right? And the then branch only calls ops again. So by definition, no matter what happens, the two branches will have the same type. Because at some point you will always just return unit. So the type of ops is basically int to unit, and then from the return type of using the return type of ops is just the return type of for loop, and so that is the return type of for loop. And therefore the full type signature of for loop is int right? Question 2, not too unclear, I hope. Question 3. Okay. Right. Question 3 asks you to write a for down to loop as well as a while loop. Let's start with the easier for down to loop. Right, what are the inputs for the for loop? How would you write this? How would you write the for down to loop? For down to loop should be quite simple, mostly because we already have a reference. How would you write the for down to?
Then from the unit to the larger or equals to 0, should it be 0?
No, wait, I'm not asking you for the syntax of the. I'm not asking you for the syntax of your camel's for down to. I'm asking you to write a function that performs the same thing as for down to. Right? You already let's make this simple, right? You already have a for loop here. Can you change this so that it now does for down to instead? What changes can we make to the for loop to make it do for down to? How can we change this function body to make it do for down to? Right? You know that this loop starts from some initial value and increases, right? So can we change this so that instead it starts from some larger initial value and then decreases instead? What are the changes that we need to make?
The ox init procs final, the I should be larger equals to init.
So
I no need to, yeah, just this one. Then
and
minus
then?
1.
-1. Okay, that works. You can also not have to change init and final, because init can simply be larger than final. That's also a perfectly valid thing to do. So these two don't have to be changed, because as long as init is larger than final, then it's simple. While loop. Well, I'm just going to give you the answer, and then I'll walk through it because it's a bit more complicated.
So complex, just ignore.
Right. So what is this doing? This is basically doing a for loop. This ops is just a recursive function, and all you do, it takes in unit because we don't really care what it takes in. As long as all it needs to do is loop, and then it just has to figure out. And then now we just have to figure out when to break the loop. When to break the loop, we have a terminating condition. We could call this cont, I guess, if it makes more sense to you. We have some condition that we need to execute to check whether this loop should end or not. Now, the thing here is that the while loop is a very generic loop, right? If you remember your while loop from like Java and whatever, the condition itself is any Boolean expression. So in order for this to work here, we need to have a condition we need a function that basically can tell us without any given input whether I should terminate the loop or not. And therefore the only sensible result here is to just tell it it's just going to invoke it with unit, which means void. There is no input to this condition. It has to figure out from wherever you wrote the original condition how to terminate the loop, which is why it's unit. It's the most general thing that we can do that gives no restriction on the possible inputs, on the possible ways that you can write a condition. Now, body is similar to statement for the for loop, right? For loop has an I all the time. It takes in some integer. The body of a while loop can do anything that it wants without reference to anything else. So the most general way that we can do is, again, similar condition, give it unit, and let it figure out from there what to do next. That's basically why the body takes in unit as well. So the type of this function, cont is body is type unit. And then the whole loop just returns unit. Any questions regarding while loop? It's a straightforward while loop. It's just that you have to think deeper as to what is the impossible inputs that you care about. In what sense do the inputs matter, and what sense do the outputs matter? And for each argument, and then you will be able to arrive at the same thing. You could probably do this in like Java, I guess. It's a bit more complicated, but you could possibly do it there. The thing is, you want to be able to the reason you do this in OCaml is that you have the type system to help you be more clear about exactly. You start thinking more clearly about what is the input, what's the output, and therefore you'll be able to write better code that way. implement a fit function with memorization using a hash table. Does anybody need me to explain what memorization is? Everybody knows what memorization is?
The previous result will be
Yeah.
stored in somewhere
Correct.
for the future.
So you just basically you're caching something, you're storing something with some previous result so that you don't have to recompute it over and over again. So the question here is to implement it using memorization. So let's call this fit mem. Taking n obviously because it's a Fibonacci function. It says use a hash table. I don't think any of you are familiar with the OCaml hash tables. So that will be I'll give that to you. So we'll create it. So let's start by creating a hash table. Let's call this table. The OCaml module for a hash table is hash tbl. The function to create the hash table is called create. It takes in a single integer that tells it what is the initial value, what's the initial size that we should create this hash table to. The hash table will expand as necessary. So the size doesn't actually matter, except for performance reasons, because the closer your size is to the actual value, the closer the size is to your expected size of the expected final size of your hash table, the less it has to do the expanding, and therefore you save time and process cycles on how many times you need to expand your hash table. So that's your hash table. We have a loop, obviously. Let's call this loop ops, as we always do. Let's call the input to ops as I. Okay, so now let's start writing our Fibonacci, how we complete our Fibonacci. What do we do? Fibonacci.
So have the base case 0 and 1.
So if n
Let's say equals to 2, then equals to 1.
lesser equals to,
I think it's 2, right? I'm not saying.
okay,
Then it will then 1.
okay, so term 1,
The first two values are 1, right? Then 2, then 3, then
okay, so the second Fibonacci starts from 0. So
0, 1, n equals to 0, then returns 0. So
I tell you what, let's do the standard. Let me give you the simple Fibonacci first, the completely unmemorized version. Right, so this is our Fibonacci function. It currently does not do memorization at all. Correct? It just computes everything over. So there's no difference. Okay. So when do we want to check the hash table? Okay, after base case. So in else branch. Right? So in else branch we want to check our hash table. What do we want to check? Okay. You want to check. You want to check your hash table directly in the else, or do you want another case? just tell me what. Just I'll give you the syntax. Just
Okay,
tell me what
now
you're.
the value, you can find the I value in the hash table.
If there exists a hash table, then
Then you just return that value in the hash, that was in the hash table.
okay. So the function here is hash table dot mem. The first argument is the hash table itself. The second argument is the key. So hash table dot mem checks whether the key, this second element is inside the set of keys of your hash table. So we check that I is inside our hash table. Then we just return hash table dot find given a hash gives you the value associated with the key if it exists. If it does not exist, it returns an exception. So this is our if it exists within the hash table, right? And then what? If it doesn't exist within the hash table, what do we do? Really sorry? If it doesn't exist within the hash table, then create a new entry, store in the hash table. Right. So to do that, what is the new value that we're storing in the hash table first? What's the value that we want to store in the hash table?
The current result
And the current result is
ops I minus 1 plus ops I minus 2.
okay. So this is the value. Let's just call this true. So we want to store this value. Okay. What is the key that we are associating with this value? So we just let the key be I. Right, and then in order to write to a hash table, we use hash table dot add the hash that we want to add it to, the key that we are writing it, the key that we want to associate, the key that we want to add, and then the value that we want to store. Right. This function returns unit. So what are we returning as the result of ops in this case? This just adds it to the hash table. It doesn't actually do anything yet. So what should we return in this final else branch?
Return to store.
Okay, yeah. So we can just return to store back into as the final result of our loop. And this is the memwise tape. We can test this out. Let's hit 30. Hopefully this will be slow enough to see. And yet the memwise version. So this is the OCaml string concatenation symbol, which is why I'm using it to join strings. This is a string. This is also a string because we say string of int, right? So we can just execute this and see.
I think we need as table.
Right. So this table. Stack Overflow. would suggest that you test it out on your own laptops to make sure that it's fine. The code is fine. I'm just not sure why it's Stack Overflowing because it makes no sense that it's Stack Overflowing. Yeah. So, and this double semicolon is used in the OCaml REPL to say the end of an expression. You can also use it in source code. What it does is that basically it explicitly says that we have come to the end of something that we have written. It possibly ends an expression. Usually it's not required because the parser is good enough that you usually not required. But sometimes you're writing something funny and strange that things get mixed up a bit, and then you need to do this ambiguity.
没有，他可以再考个吗？
Please make sure you try this one because I'm not sure whether you really should not Stack Overflow. But some people you should try and make sure that it's not Stack Overflowing on your own laptops. If it is, then there's probably something wrong with the code.
好吧。
Right. That's the end of the tutorial. Lab solutions are up. You can go check them out. Lab 4 is due. I'm not sure when. Does anyone have problem with setting up Lab 4 first? Do you at least manage to compile Lab 4? The initial compile. Initial compilation is fine, right? If the initial compilation is fine, then you can probably start working on it already. Right? Install stack. Stack build will be your initial compile, and things should just work from there. Does anybody have problem with getting it to compile first? No? Yes? No? It will compile even if it doesn't solve it must compile it even if it doesn't solve anything first. Does it compile?
Wait.
Yeah.
Just now that code.
Uh-huh.
Fib 0 is okay.
Sorry?
Fib 0 is okay. Fib 1 has problem. The first.
One has problem.
So 1 is not in the hash table. 3 is not Fib 0 in the hash table.
So 0 and 1 is hash table because you can just default to this. Right?
Oh. Let's reduce to Fib 1 is okay. Fib 2 is.
Oh, sorry, this should be I. That should be I.
Yeah.
Yes. Slight error. It should be mostly the same. So if you say 30 here. Yeah, there's some off by a bit errors here and there. You have to decompile the whole thing. Yeah, there's an off by one error somewhere. But yeah, you can't really tell it here that. I don't think you can really tell the difference here because it doesn't print. It won't print fast enough.
啊，overflow。
I think in Fib 2 it starts to show differences. Just a very simple Fib 2.
Yeah, it's an off by tell the difference between the runtime here because the web will compute the entire thing first before it displays. You want to test it out, you're gonna have to do it on your own REPL and call the two functions with the large values, and then you should be able to tell that there is a difference. And it's actually a lot faster with the memorization. Right. Right, back to lab 4. Everybody, if you, nobody has problems compiling first, right? Whether you think the answer is a different story, but you can at least compile the code and make it run, right? So that's good. That means that you can start working. As long as that's your first sanity check, that everything that it compiles, then you can go to add in your code to do the necessary task. One last thing I guess is that please stop copying each other's code. Like it is very, very obvious when you have to mark 24 people's code that there are extreme similarities between people's code. For lab 4, it will be super insanely obvious if you copy, because it's a lot more freeform than the previous labs. And if you do that, we're going to escalate this upwards for obvious reasons, because you really shouldn't be copying your code. You're not learning anything. If you're not going to heed people telling you that don't do this kind of things, then we'll have no choice but to bring the school into this, right? And if the school comes in, trust me, it's not pretty. So don't. I don't mind people discussing, because discussing is how you bounce ideas off each other. But you really should be writing your own code. And if you're not writing your own code, then what are you doing all this lab for? You're just wasting everybody's time, right? So that's mainly that's all I wanted to say about the labs.
So can I see the last answers again?
Okay, sure.
Yeah, okay. I think the I smaller than equals to 1 and I, if you put it to then 1, then it will
Oh,
算了，有工作。
50 IS.
Right.
靠，吃饭去。
Any questions? Any further questions? No? I guess we can take you can take a 5-minute break or more.